Yeah, it is getting recorded. Please, all of you write these points in your notebook. Nodal analysis in bracket. Please, in bracket, write nodal analysis. The nodal analysis. KCL plus Ohm's law. Nodal analysis. KCL plus Ohm's law. After writing some theory concept, I will explain the problems. All of you listen carefully. This is the very important concept. And so far we have discussed only theory. Now we are going to solve problems. Yeah. First, write down the first steps. There are some steps to follow. Write down the first step. Identify the number of nodes in the given circuit. Please write. First point, nodal analysis. First, write down this point. Identify the number of nodes. Okay. Next, second point, write down. Assign the node voltages. Please write. Assign the node voltages. Assign the node voltages. I hope everybody is writing. Assign the node voltages with reference to the ground node. With reference to the ground node. Assign the node voltages with reference to the ground node, whose voltage is always equal to 0. Whose voltage is always equal to 0. Yeah, please add, identify the number of principal nodes and random. Principal nodes. Principal nodes. Add 1 point here. Identify the number of principal nodes and assign the node voltages with respect to the ground node, whose voltage is always equal to 0. Next point is, by using the KCL first. By using the KCL first and Ohm's law next. By using the KCL first and Ohm's law next. Write the nodal equations. Write the nodal equations. Write the nodal equation. By using the KCL first and Ohm's law next, write the nodal equations. So all of you write these 3 steps under nodal analysis. Completed, Amma? Please respond.
Yes, sure.
Yeah. Now, after writing these steps, I will explain each and every step one by one. Don't worry. Now, again, so after having these steps, please note down this problem. All of you note down this problem here. Find the currents and wait for a minute. This problem is related to mesh, I think so. Let us take this problem. Please. I already sent this material to you. You can also verify this one later. See here. Find the currents. No, not on this problem. Find the currents and voltages in the circuit by using nodal analysis. Find the currents and voltages in the circuit by using nodal analysis. Note down the circuit, all of you. Please, all of you note down the circuit. Meanwhile, I will also draw the circuit on whiteboard. Please, all of you note down that problem. Yeah, completed. All of you note down the problem.
Yes, sir.
Okay, okay. Mm, 2 ohm, 4 ohm, and 8 ohm. 2 ohm, 4 ohm, and 8 ohm. Next, I1, I2, I3 currents. Okay. Please. Now, I shared the whiteboard. Please respond. Is it visible?
Yes, sir.
Yeah. Now, all of you listen carefully here. I'm going to solve this problem by using the nodal analysis. They won't ask by solve the problem nodal analysis like that. They will give like this: calculate the current through particular resistor by in the following circuit. Like that, they will tell. So, what is the nodal analysis here? You have to apply KCL, Kirchhoff current law plus Ohm's law. First KCL and next Ohm's law. Next, what is the first point we have to follow? Identify the number of principal nodes. Principal nodes. What do you mean by a principal node, please? Please respond. What do you mean by principal node? What you discussed? First of all, anybody tell me what is how many nodes are there in the circuit here? So interconnection of the branches. First of all, how many branches are there? 10 volts is one branch, 6 volts is another branch, 2 ohm is another branch, 4 ohm is another branch, 8 ohm. Total 5 branches are there. Okay, 5 branches are there. And node, what is a node? Interconnection of the branch elements. Suppose if you take this 10 volts branch and 2 ohm branch connected here. But how many branches are connected here? Please respond. How many branches are connected here? Please, anybody respond. Otherwise, I cannot.
Two, sir.
Yeah. So, number of branches which are connected at this node is N1 and 2. Now, at this particular node N2, please tell me how many branches are connected here?
3, sir.
3. 3. Next, at this node, how many branches are connected? Again 2. And this is I will come to this point later. Here also 10 volts branch, 8 volts branch and 6 volts branch is connected here. This is also another node, but which is known as a ground node, whose voltage is equal to 0. That voltage, ground node is known as a whose voltage is equal to 0. Now, including this ground node, this is known as a ground node. In electrical engineering, there is a term called ground. The ground node voltage is always 0. Now, so here we have to identify number of principal nodes only. What is the difference between simple node and principal node? I already gave what you call discussion about the simple node. What do you mean by simple node? Number of branches incident. N number of branches incident at a particular node equal to 0, that will be considered as a simple node. Yeah, tell me what is the type of the node 2? What is the type of the node? Is it a simple node or principal node?
Principal node, sir.
This node, this node. Any branches connected? Huh?
Simple node.
That is simple node. Simple node. So, simple node should not be considered in nodal analysis. No need to consider the simple node. Or even a principal node. If number of branches greater than 2, at least 3, that is known as a principal node. Suppose if you observe this node, 1, 2, 3, 3 elements or 3 branches are connected here. So this is known as a principal node. And what about this node? Only 2. This is also a simple node. This is also a simple node. Okay, na? So what I am trying to say is that we have to identify the number of principal nodes only, not simple nodes. Simple nodes should not be considered for this nodal analysis. Only principal nodes we have to consider. If you consider this as a principal node, please see here. That is, we identified this node as a which node, Amma? Which node? Principal node. Let us say node 1. Okay, na? Second point is, so how many principal nodes are there? Principal node is 1. Okay, and there is a ground node. Ground node is, this is a ground node. Now, what is the second point we wrote? Please, can you read out? Anyone? Please. All of you listen this theory carefully. Once if you understand how to solve this problem, you can solve any problem by using the nodal analysis. What is the second point, Amma? Please, Maheshwari, can you read out? Assign the
Assign the node voltage with reference to the ground node, whose voltage is always equal to 0.
Yeah. See, you have to assign the node voltage. At each and every node, there is some voltage. But here, we don't know the voltage, how much voltage is present here. We don't know that voltage. So, we have to assign the node voltage with respect to ground voltage. Suppose if you see this node, can you tell me how much voltage is present? ఈ నోడ్ దగ్గర ఎంత వోల్టేజ్ ఉందో చెప్తారా? అంటే ఒకే బ్రాంచ్ ఉంది కాబట్టి చూడండి కొన్ని విత్ రెస్పెక్ట్ టు గ్రౌండ్ ఇక్కడ 10 volts ఉంటుంది కదా, ఈ నోడ్ దగ్గర కూడా 10 volts ఉంటుందన్న. అంటే ఇక్కడ ఐ నో ది 10 volts, there is a 10 volts, but can you see how much voltage is there at this particular node? We don't know. This is this node voltage, so we don't know this node voltage because there is some drop, current flow అవుతుంటే ఇక్కడ కొంత డ్రాప్ ఉంటుందమ్మా ఈ 2 ohm resistor దగ్గర. We don't know that will drop. So as we don't know that will drop, so this is unknown voltage. That unknown voltage should be marked as V1. Or if in some of the problems there are two nodes, then you can have a V1, V2 like this. So here I assigned the node voltage V1 at a principal node with respect to ground node, and ground node is always 0. So already we marked the ground node. So we have to assign the unknown voltage at each and every node. Each and every node the node voltage is available. So in the similar manner, how much voltage node voltage is present here? With respect to ground, it is a minus 6 volts. ఎందుకంటే polarity చూడండి ఎలా ఉంది. ఓకేనా, this is minus 6 volts and this is plus 10 volts. Now after assigning the node voltage, what is the third point, Amma? Please read out, Maheshwari, please. What is the third point? Second point is
By using the KCL first and Ohm's law, next write the node equations.
Yeah, assign the node voltages. We assign the node voltages. Next, by using the KCL first and Ohm's law next. What is the KCL here? You know, algebraic sum of all currents which are leaving or entering at a particular node is equal to 0. Where you have to write the KCL here at a particular node. At node, let us say this is node 1. At node 1, I am going to write the KCL first. What is the KCL here? To write the KCL, so we should have the currents here. Currents kavalama. So currents and already unknown voltage is there. Now here remember one thing is that while writing the node KCL, you have to imagine that this node voltage is greater than node. There is a node. The note is that while writing KCL at a node, while writing KCL at a node, you should assume that the node voltage is greater than, please all of you write, greater than all voltage sources in the circuit. Please all of you write this note. While writing the KCL at a node, all of you write down. While writing KCL at a node, we should assume that the node voltage is greater than all voltage sources in the circuit. Okay, all of you note down. This note is very, very important. So what I'm trying to say is that this node voltage is higher. Suppose, see, there is a 10 volts is here, and this is 2 ohm, and this unknown voltage is V1. Here. What I am trying to say is that this voltage is higher than this voltage. this is greater, this V1 is greater than 10. As it is greater, so current will flow from higher potential, higher voltage to voltage potential kuda antaramma, higher voltage to lower voltage. Then what will be the direction of the current? The direction of the current will be in this direction. Okay. So always current flows from higher potential to lower potential, or higher voltage to lower voltage. As we are assumed that this V1 is greater than all voltages, V1 is greater than 10 volts. So how the current is flowing? Higher potential, like water is flowing from higher level to lower level. Here also current is always flows from higher voltage to lower voltage through a resistor. So then the current is flowing in this direction. And here this is a ground voltage, and here also the current is flowing in this direction. And here also the current is flowing in this direction. Because this V1 is greater than this 6 volts also, minus 6 volts. I hope everybody is following. That means all the currents are going to be living. All the currents are going to be living, because we are assuming that this V1 is greater than all voltages which are present in the circuit. Just that is our assumption. Then only you can write the KCL equations. Okay, na? So let me take, this is I1 current, this is I2 current, 8 ohm, and this is I3 current. All are living currents. All are which currents, Amma? Living currents. Okay. Now, we have to, after writing the currents, after giving the direction for the currents, all are living currents. Now tell me, all the currents are living currents. Now tell me the KCL at this particular node. Please all of you respond. KCL చెప్తారా? ఎన్ని కరెంట్స్ ఉన్నాయమ్మా ఈ నోడ్ దగ్గర? Please respond.
3, sir.
3 currents. Now tell me the KCL at this node. All are living currents. What is the KCL? Entering,
Minus I1,
minus
minus
I1
I2, minus I3
equal to
equal to 0.
very good. So as minus is common for each and everyone, so I am writing I1 plus I2 plus I3, which is equal to 0. So if I take a minus common, then I can write this equation. This is, let us say, equation 1. KCL complete ayinamma. Okay na? Now come to the Ohm's law here. Come to the Ohm's law here. What is the Ohm's law? According to the formula, what is the Ohm's law? I ki formula and what is the I1 here?
Is equal to IR.
I equal to V by R. Okay, but I1 is what? Here, if you have only this resistor and this voltage is V1, like then you can write V1 by 2. Directly you can write. But there is some potential is 10 volts. At the time, how to write that Ohm's law? I will explain. Listen carefully, all of you. Let me take another slide for easily understanding. Plus to minus. Here the polarities are reversed here. Please observe those things here. This is 10 volts. This is 2 ohm. ఈ రెసిస్టెన్స్ ఎంతమ్మా?
8 ohms.
This one 10 ohms,
4 ohms, sir.
this is 4 ohms. Now see here, this current we are we assigned the node voltage as V1, and as this V1 is higher than all voltage in the circuit, current is leaving I1, I2 and I3 currents are leaving, and we wrote the KCL here. That KCL is I1 plus I2 plus I3, which is equal to 0. Now if you take I2 current, directly there is a ground node. So V1, if there are two voltages are there, suppose let us take a 2 ohm resistor is there, and there is a V1. I am writing separately this branch, 2 ohm branch, and if this is a 10 volts, and there is no drop in this one because there is no resistance here, so here also there is a 10 volts. Okay, na? If there is a 10 volts here, and this is 10 volts, and this is V1, and this is the current I1. In this case, how to write the I1 current? I1 equal to, actually formula is V by R, but here we have two voltages here. Then you have to write potential difference. What should you write? Potential difference rayalam. You have to write potential difference. Potential difference means voltage differences. Difference between this one and 10. And you have to consider this polarity also, this plus. This polarity plus means here also there is a plus. V1 potential difference kada. This one minus this voltage rayal. Only single voltage is there, then we can write only V1. But here we have two voltage, potential differences are there. So you have to write V1 minus 10, because it is a potential difference. There are two voltages. V1 minus 10 is the voltage divided by R. What is the R value? 2 ohms. So this is the current I1. So similarly, tell me the current I2 here. I2 current is, which is the I2 current flowing through the 8 ohm resistor. Here also I am taking separately here. This is V1, and what is the ground voltage here? 0. This is 8 ohm resistor. Now tell me what is the I2 here? V1 is the voltage, and this is the 0 voltage. V1 minus 0 by 8, that is I2. So similarly, can you tell me I3 here? I3 ఎవరన్నా చెప్తారమ్మా? I3 ఏంటి? Current flowing through the 4 ohm resistor, but here there is a 6 volts, and here at this simple node minus 6 volts is present, because you have to consider this polarity. Initially minus is there, you have to write minus. You have to write minus 6 here. Okay, na? And this is minus 6 volts, and this is V1. Now current is flowing in this fashion, I3 current. Please tell me what is the I3 current here after discussing these three. What is the I3? Can anybody tell me? ఇక్కడ ఎలా రాయాలి?
6/8 4 sir.
V1
6/4.
very good, very nice. V1 minus of 6 by 4, which is nothing but V1 plus 6 by 4. Very good. So these are the currents. Next time నేను ఇవన్నీ యూజ్ చేయను, డైరెక్ట్గా ఇక్కడ ఫార్ములాలో రాస్తాను, మీకు అర్థం కావాలని ఇది ఈచ్ బ్రాంచ్ తీసుకొని చెప్తున్నాను. యాక్చువల్లీ నో నీడ్ టు write all the things. Directly you can write Ohm's law here. So after having these things, we can write directly. ఇది నోట్ చేసుకోండి ప్లీజ్. ఆల్ ఆఫ్ యూ నోట్ దిస్ ఫర్ యువర్ రిఫరెన్స్. నోట్ చేసుకోండి అమ్మా. ఇది I1 కరెంట్ ఎలా రాశాను, I2 కరెంట్ ఎలా రాశాను, I3 కరెంట్ ఎలా రాశాను సపరేట్గా నోట్ చేసుకోండి. ఇక్కడ నేను జిగ్జాగ్గా రాయవచ్చు, మీరు 1 by 1 నోట్ చేసుకోండి. ఇది I3 కరెంట్, ఇది I1 కరెంట్కి రాశాను సపరేట్గా తీసుకొని, I2 కరెంట్కి రాశాను. ఆల్ ఆఫ్ యూ నోట్ డౌన్. మీరు ఈ నోడల్ అనాలిసిస్ అర్థం చేసుకోగలిగితే మీరు ఏ ప్రాబ్లం ఇచ్చినా కానీ చేయొచ్చు అన్న. యూ కెన్ డూ ఎనీ ప్రాబ్లమ్ ఇఫ్ యూ అండర్స్టాండ్ దిస్ నోడల్ అనాలిసిస్ క్లియర్లీ. సో ఆల్ ఆఫ్ యూ లిజన్ కేర్ఫుల్లీ. Please all of you note down how to write this I1 current. I1 ఎలా రాశాను, I2 ఎలా రాశాను, I3 ఎలా రాశాను నోట్ చేసుకోండి. Please all of you note down. And if anybody have any doubts, you can ask. We posted the video, recorded video lectures in Google Classroom. All of you check those classes and please download those classes, and you can save a particular folder. If you have a laptop, please save those video lectures in particular folder, or please save in mobile also in a particular folder, because I may delete later, because Google Drive permits only 15 GB. The 15 GB is full, then I may remove those classes. Please all of you download those classes and save for your reference. I hope everybody is writing notes. All of you go through that classes and write the notes. Yes, for writing running notes, well and good. Or unable to writing the notes, go through those classes and write the notes clearly. Completed? Shravan, 188.
Yes, sir.
Note చేసుకున్నావమ్మా?
Sir.
Okay, right. Now let us substitute these currents in this equation 1. ఇంతకుముందు రాసాం కదా KCL equation I1 plus I2 plus I3. అక్కడ substitute చేయండి. I think it is better to erase. See, once we understand these things, no need to write I1, I2 separately. We can directly substitute in this equation. Now here I am writing directly I1. What is the I1 current? V1 minus 10, potential difference. V1 minus 10 by 2. So V1 minus 10 by 2. Next, that is I1 plus what is the I2? V1 0, V1 minus 0 by 8. That means V1 by 8 plus what is the I3? V1 minus V1 minus 6 volts. So that becomes V1 minus of minus plus 6 by 4, which is equal to 0. Now, so let us take the LCM for this problem, LCM for this equation. What is the LCM here? 8. Here 4 into kada, 4 into V1 minus 10 plus, I am going to calculate V1 here, and V1 plus 2 into V1 plus 6, which is equal to 0, which implies that 4 into V1 minus 40 plus V1 plus 2V1 plus 12 equal to 0. Now this is 4V1, V1 and this 2V1. Total it will be 7V1 which is equal to 40 minus 12 ఎంత వస్తుందమ్మా 28 okay so then v1 equal to how much 7 అంతేనా calculations which is equal to 4 volts so what is the unknown voltage here v1 equal to 4 voltage so after calculating this unknown voltage v1 then we can calculate i1 here i1 ఎంత చెప్తారా i1 ఎంతమ్మా we know v1 what is the i1 here already we know v which is equal to 4 minus 10 4 minus 10 by 4 minus 10 by 2 which is equal to how much minus
3, sir.
20 minus 3 amperes here you should understand that minus 3 amperes but here we have considered the minus sign here the minus sign indicates initial these are only assumption we made initially this v1 is greater here the current is i1 current is let me erase this clearly ఇక్కడ i1 అనేది minus 3 amperes వచ్చిందమ్మా where this minus shows the direction of the current the minus indicates only a direction okay na if I write in this direction that will be minus 3 amperes suppose if the direction is reverse amma ante all of you listen very carefully here it is very important concept this is minus 3 amperes so this minus indicates a direction and if you write like this this i1 will be 3 amperes all of you because if you take this resistance 2 ohms మనం ఎలా రిప్రజెంట్ చేయొచ్చు అంటే కరెంట్ ఇలా i అనేది ఫ్లో అవుతుంది అనుకోండి ఇది అనేది 2 amperes అనుకోండి if I is 2 amperes in this direction same current if I want to represent in this direction this will be minus 2 amperes where minus indicates only a direction of the current okay na direction of the current so we have to observe that point very clearly magnitude that value is same but minus sign you have to change so in this direction it is minus 3 amperes but in the problem what is the direction is shown please tell me in the problem the given problem what is the direction is shown ఏ డైరెక్షన్ చూపించారమ్మా ప్రాబ్లంలో డైరెక్షన్ ఈజ్ ఫ్రమ్ ప్లీజ్ డైరెక్షన్ ఈజ్ గివెన్ ఇన్ దిస్ డైరెక్షన్ i1 ఇప్పుడు i1 వాల్యూ ఎంత చెప్తారా ఈ డైరెక్షన్లో i1 ఎంత what is the value of i1 in this direction are you getting me or not hello am I audible please respond ఇక్కడ మీకు క్లియర్ అయితే మిగతాదా ఎంత కరెంట్ అంటే కరెంట్ మ్యాగ్నిట్యూడ్ సేమ్ ఈ డైరెక్షన్ లో చూస్తే మ్యాగ్నిట్యూడ్ ఎంత అవుతుందమ్మా రమ్య
plus 3 amperes sir.
దట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ మైనస్ అండ్ ప్లస్ అంటే ఇనిషియల్ గా మనము కరెంట్స్ ఆర్ లీవింగ్ అనుకున్నాం కదా ఇంతకుముందే చెప్పాను మీకు ఇదేమో 10 volts ఇక్కడ అన్నోన్ వోల్టేజ్ V కదా ఇంతకుముందు అన్నోన్ కాబట్టి మనము అదొక రూల్ వైల్ రైటింగ్ ది నోడల్ ఈక్వేషన్స్ ద రూల్ ఈస్ దట్ all this is higher potential అనుకోవాలి but after calculating this voltage is how much 4 volts but ఇప్పుడు కరెంట్ ఎలా ఫ్లో అవుతుంది ఇప్పుడు హైయర్ పొటెన్షియల్ ఏది 10 volts is higher potential అంటే కరెంట్ ఇలా ఫ్లో అవుతుంది 10 volts to 4 volts ఫ్లో అవుతుంది ఎంత కరెంట్ వచ్చింది? 3 ఆంపియర్ వచ్చింది. అంటే ఈ డైరెక్షన్లో 3 ఆంపియర్ ఫ్లో అవుతుంది. బట్ ఈ డైరెక్షన్లో చూపించాలంటే ఎట్లా? -3 amperes. I hope this point is very clear to each and everyone, because sometimes they may ask the current, they may give the current direction and they will ask what is the current. So you have to very careful with these signs. If anybody have any doubts, you can ask. And similarly, please calculate this I2 and I3. ఈ I3 I2 కూడా చెప్పండి నాకు ఎంత వస్తుందో. I1 is ఆ డైరెక్షన్లో -3 amperes. I2 కరెంట్ ఎంతో చెప్పండి అమ్మా ప్లీజ్. I2 కరెంట్ ఎంత? ఇక్కడ ఆల్రెడీ నోడ్ వోల్టేజ్ తెలిసింది కదా, ఎంత? 4 volts.
5 sir.
Which one?
I2 sir.
I2 ఎంతమ్మా?
0.5 amperes.
Okay, very good. That means V1 నోడ్ వోల్టేజ్ ఎంత? 4 కదా. అండ్ ఎంత రెసిస్టెన్స్ ఆఫర్ చేస్తుంది? 8 అంటే 1/2 అంటే 0.5 amperes. నోట్ చేసుకోండి. ఓకేనా? In a similar fashion, calculate I3.
2.5 sir.
2.5.
5.
Why? Because V1 is 4 plus 6/4. అంతే కదమ్మా. 10/4 2.5 amperes. క్యాలిక్యులేట్ చేయండి. ఇంతకుముందు ఫార్ములాస్ ఉన్నాయి కదా, అట్లా సబ్స్టిట్యూట్ చేయండి. బట్ ఇక్కడ ఏంటి? కరెంటు డైరెక్షన్ పాజిటివ్ వచ్చింది కదా. We got to, the current direction is positive. That means the current is, whatever the things we have assumed are correct. Now let me draw here again. This is 4 volts after calculating. This is 2 ohm. ఈ డైరెక్షన్లో అయితే ఎంత కరెంట్ ఫ్లో అవుతుందమ్మా? ఇన్ దిస్ డైరెక్షన్ 3 ampere కరెంట్ ఈజ్ ఫ్లోయింగ్ అండ్ దిస్ ఈజ్ 8 ohm. I2 ఎంత చెప్పారు? 0.5. 0.5 I2. I3 ఇది 4 ohm అన్నారు కదా. I3 ఎంత? 2.5. This is 6 volts. Now we have to calculate the voltages across each and every branch. ఇక్కడ అసైన్ చేశారా కరెంట్స్? ఏమేమి క్యాలిక్యులేట్ చేయమన్నారు మనల్ని? V3 V2 అండ్ V1. V3 ప్లస్ మైనస్ V2 V1. ఇప్పుడు చెప్తారమ్మా V3 ఎంతో? V1 ఫస్ట్ V3 క్యాలిక్యులేట్ చేయండి. వోల్టేజ్ అక్రాస్ దిస్ రెసిస్టర్. V equal to I into R కదా ఫార్ములా. How much current is flowing? 2.5 amperes. 2.5 into what is the resistance here? 4. ఎంత వోల్టేజ్ అమ్మా? 2.5 into 4 అంటే 10 volts. అలానే ఈ వోల్టేజ్ క్యాలిక్యులేట్ చేయండి. V2 కరెంట్ ఈస్ 0.5. R is 8. 4 volts. ఓకేనా? నెక్స్ట్ V1. This current is 3 amperes. 3 into 2 ఎంతమ్మా? 6 volts. చూడండి ఇక్కడ 10 volts ఉంది కదా, ఇక్కడ 6 volts డ్రాప్ అయ్యేసరికి ఇక్కడ 4 volts వస్తుంది, రైట్? So these are the voltages and currents. I1 equal to 3 amperes, I2 equal to 0.5 amperes, I3 equal to 2.5 amperes. Please note down all of you. మన డౌట్స్ ఉంటే అడగండి అమ్మా స్టార్టింగ్లోనే. Completed? Anybody have any doubts in this, please? శ్రావణ్ డౌట్స్ ఏమైనా ఉన్నాయమ్మా? ప్రవీణ్ కుమార్, ఉదయ్. If anybody have any doubts, you can ask. Completed? Maheshwari, completed amma?
Yes, sir.
Yeah. So based on this, let me give another problem here, please. See. For the circuit shown in figure, find the node voltages. For the circuit shown in figure, find the node voltages in the follow. For the circuit shown in figure, find the node voltages. Now note down this problem. Sorry. Plus V minus is 10 volts. This is 1 ohm. And this is 5 ohm. This is 2 ohm. It's 10 ohm. And for the change, there is a current source, not voltage source, current source. Here in this, I will write the nodal equations. All of you listen carefully. Here we have to calculate this node voltage and this node voltage. I want to calculate this V1 and otherwise, what is the V1 and V2 node voltages? V1 and V2. Now, how many principal node? Please respond quickly. We have left with only 2 minutes of time. I will write the nodal equations. You solve and try to solve this problem at your home. How many principal nodes are there? Please.
2, sir.
2. So this is one principal node. Let us say V1 here, and this is another principal node V2. Okay. Now, and this is ground node. This is ground node. ఇదంతా కలిపి గ్రౌండ్ నోడ్ అంటారమ్మా. ఇదంతా గ్రౌండ్ నోడ్. సింగిల్ నోడ్ కదా, వీటి మధ్య ఏం ఎలిమెంట్ లేదు కాబట్టి ఇది గ్రౌండ్ నోడ్. ఇది 2 ఆంపియర్ కరెంట్. Current is 2 ampere. Now, by using the nodal analysis, at node 1, here we have to write 2 nodal equations. At node 1, what is our assumption? This node voltage is greater than all the voltages which are present. Greater and all currents are leaving. This current is leaving, this current is leaving, and this current is leaving. So this, let us say I1, I2, I3. Now tell me the nodal equation directly. Direct ga cheptara evarunna? Please. Please respond anyone. Ramya?
Yes, sir.
చెప్పండి అమ్మా, నోడల్ ఈక్వేషన్ చెప్పండి. I1, actual I1 plus I2 plus I3, which is equal to 0. Next, what is I1?
V1 minus 10 by 1
1, very good, plus
plus V1 by 5
V1 by 5 plus చూడండి ఇక్కడ
V1 minus 2, sorry, V1 minus 10 by 2.
10 ఎక్కడ ఉంది తల్లి మళ్ళీ? V1 మైనస్, చూడండి ఇక్కడ ఈ యొక్క 2 ohm బ్రాంచ్ తీసుకుంటాం కదా, ఇక్కడ వోల్టేజ్ ఇక్కడ V2 ఇక్కడ V1, ఓకేనా? అంటే ఈ సెకండ్ టెర్మినల్ దగ్గర ఉన్న వోల్టేజ్ అన్నోన్ వోల్టేజ్ V2నే, అది V2 గానే తీసుకోవాలి, ఓకేనా? ఈ I3 కరెంట్ ఏమవుతుందంటే V1 మైనస్ V2 by 2 అవుతుంది. V1 మైనస్, అర్థమవుతుందా? వై? బికాస్ ఇఫ్ యూ టేక్ దిస్ రెసిస్టర్ 2 ohm, ఇక్కడ V1 వోల్టేజ్ ఉంది, ఇక్కడ V2 వోల్టేజ్ ఉందమ్మా. సో V1 ఈ కరెంట్ ఏమవుతుందంటే V1 మైనస్ V2 by 2, అన్నోన్ వోల్టేజ్, బోత్ ఆర్ అన్నోన్ వోల్టేజెస్. V1 minus V2 by 2, which is equal to 0. Let us equation 1. And at node 2, ఇక్కడ కూడా ఈ node 2 దగ్గరే కన్సిడర్ చేయాలి. So this current is leaving, this current is leaving, because you have to imagine that current is higher than all the voltage higher than all the voltage. So current is leaving. ఇక్కడ చూడండి, నేనే రాస్తాను చూడండి. సో ఈ కరెంట్ ఇక్కడ ఇట్లా ఫ్లో అవుతుంది కదా, సో దీన్ని I4 సేమ్ కరెంట్ ఉంటుంది కాబట్టి I3 అనుకోండి, I3, I4, I5. సో I3 ప్లస్ I4 ప్లస్ I5, విచ్ ఈజ్ ఈక్వల్ టు 0. వాట్ ఈస్ ద I3 ఇప్పుడు చెప్పండి అమ్మా? ఇంతకుముందేమో V1 మైనస్ V2 రాశారు కదా, బట్ వీఆర్ రైటింగ్ ది nodal equation at this node, so it will be greater. Wherever you are writing the nodal equation, that voltage will be greater. Now in this case, what will be the node, this current I3 will be V2 minus V1, like that you have to write V2 minus V1 by 2. Next, plus this current is how much? V2 by 10. Now come to the point here. This current is imagined that this is I5 current, but here it is a current source or voltage source? Please respond amma.
Current source, sir.
Current source ante direct ga manaki current telusu kada, directly we know I5 whatever the current which is leaving, we know that current, but we have to what you call show the direction, concentrate on. We assumed that this current I5 is in this direction, but the current current direction ఎలా ఉందమ్మా? How this current direction is available? మనకి I5 ఏమో డౌన్వర్డ్ లో ఉంది. Now we can say I5 is same as 2 amperes. I5 కరెంట్ మనకి 2 అని తెలిసిపోతుంది. ఇక్కడ ఏమి ఇక్కడ వోల్టేజ్ సోర్స్ కాదు, కరెంట్ సోర్స్ ఉంది కాబట్టి ఆల్రెడీ యూ కెన్ డైరెక్ట్లీ టేక్ దిస్ కరెంట్. But the direction, whatever the direction you have imagined, it is downward. But the 2 ampere current ఏ direction లో ఉందమ్మా? మనం ఇమాజిన్ చేసుకున్న కరెంట్, లిజన్ కేర్ఫుల్లీ, డౌన్వర్డ్ ఉంది. బట్ ఈ ప్రాబ్లంలో ఇచ్చిన కరెంట్ ఎలా ఉంది? అప్వర్డ్ ఉంది. కాబట్టి మీరు ఏం చేయాలంటే మైనస్ రాయాలి. సో మైనస్ 2 amperes ఈజ్ ఈక్వల్ టు 0. అదే ఈ కరెంట్ డైరెక్షన్ డౌన్వర్డ్ ఉంది అనుకోండి అమ్మా, మనం ఇమాజిన్ చేసుకున్న కరెంట్ కూడా డౌన్వర్డే ఉంటుంది. సో దెన్ వీ హ్యావ్ టు రైట్ +2, because we are writing the current equation directly. There is a current source. As there is a current source, you can directly take the 2 amperes, but you should consider the direction of the current. So this is the second equation. And if you solve 1 and 2, you solve equation 1 and 2, you will get V1 and V2, and those are the answers. He is asking what is the V1 and what that is the V2. So if anybody have any doubts, you can ask. I stop here. I'm taking the attendance because we are running out of the time. Please. Problem solve cheyandi ee lopalo. Let us see. Now write these equations on your own and check those answers. మీరు ఓన్గా రాసి చెక్ చేసుకోండి. 46,
Present, sir.
47,
Present, sir.
48, 48 అమ్మా. 48 absent. 49,
Present, sir.
50,